So I'm here with Tim Froelich of Lynx Software Technologies. What do you do for Lynx, Tim?
I work on training, I work on demo creation, I do some sales calls, I do a little bit of everything.
Okay. And I understand that you are the expert on Lynx Secure.
Yes.
So tell me, what is Lynx Secure?
Lynx Secure at its core is a pure bare metal hypervisor. It's not an operating system. It's basically a level of firmware that's going to run on top of the BIOS, and it's going to partition the system into different pieces.
Okay.
Those partitions are CPU cores, they're chunks of memory, they are devices, and you can run different operating systems in those, or you can run real-time operating systems or pure C applications.
Okay. And how does that help?
That helps if you need to have different levels of criticality, different types of software running on your system. Basic example is you have a system that needs to always do the right thing every time, no matter what. It needs to read the camera input coming in, and it needs to process that data and output it the right way to another piece of the system. But you still need to control that system. You still need to have communication to come in that to control the system. You still need to have those communications secure.
Okay.
If you put all that into one big thing, you're talking about millions of lines of code all running right next to each other, all that can have potential threats or bugs or exploits in them. With Lynx Secure, what you would do is put all that communications and security. You probably use an entire operating system like Linux to support all that. Have that running in one core. Have it do just small communication to some pure C applications or to a real-time operating system. That runs separately, so it's always doing the right thing no matter what. It's occasionally getting a configuration input, but if you break that Linux, you won't break the sensing part, you won't stop that from happening.
Okay. So I understand the real strong reason for this is that this is a way to close the hole for meltdown to Spectre.
Yeah. Lynx Secure was basically immune to meltdown before anyone publicized meltdown.
Okay, why is that?
Lynx Secure, so number one, when we designed Lynx Secure for safety and security first, we designed it to keep everything separate. We didn't want to have any way for our virtual machines to interact with each other unless we explicitly wanted them to. And because of that, we kept them in their separate page tables, completely separate page tables, rather than having them all in one with permission bits that say, no, you can't do that. Meltdown exploits having everything in one page table and with little permission bits that you try that you work around. But because Lynx Secure was already trying to keep things separate, everything is already in its own little boxes, and Meltdown can't get outside of those boxes. Now, Meltdown is still a threat inside the virtual machine because the virtual machine still uses that same thing. But from one virtual machine to another, Meltdown can't get between them because they were already separated.
Okay, so would you call this a patch to the overall problem, or is this a complete solution to that particular hole?
Mostly, I would probably describe it as a mitigation.
Okay.
Because if you have...
Well, in other words, if it's in the virtual machine, you still have a problem. But this is a way to keep it from spreading.
However, if you have, if you keep all your security portions separate in a separate virtual machine, if you have all of your keys in that separate virtual machine, separate from the networking, then someone can come in and execute a meltdown attack on your networking virtual machine, but they won't be able to break into your keys virtual machine. Now, just most other virtual, the first publicized meltdown attack involved Linux KVM, which uses virtual machines running on a Linux operating system. It's not true for there. Because fortunately, Meltdown became public after the patches had begun to be released, so I believe the attack is limited. But because Linux KVM supporting different virtual machines runs on a Linux operating system, all those virtual machines are running in the same page tables, in the same address space. So a meltdown attack on one lets you get to the other virtual machines. VM breakout attack. But because Lynx Secure keeps those virtual machines in completely separate agile spaces, that same attack would fail.
Okay. How is this different? Okay, there are a lot of RTOS companies around here, Green Hills, for example, in the way, that says they've got a secure RTOS as well. How is this different from what they do? Or should I go ask them?
Well, this is, when it comes down to it, we allow you to have secure RTOSs, and we allow you to have completely insecure operating systems running on the same system, but still kept separate from each other.
Okay.
So you would want to have your real-time operating system doing exactly what you need to do as perfectly, as securely controlled as possible. But you might need a Windows because your control applications is written in Windows. You can have that Windows running on a different virtual machine and not have it be able to affect the real-time operating system, and not have it be able to attack or break the real-time operating system. So we do have our own real-time operating systems that are integrated with Lynx Secure, LynxOS 178. But you can still use just about any real-time operating system that you want on top of Lynx Secure and have the extra layer of security of separating things into separate
Okay, so
boxes
this is
that
not
can't be
necessarily a competing product to what Green Hills is doing.
It's in the same space, but it's a
Although
different
Green
way
Hills
of
might-
thinking about the problem.
Or Green Hills might say something else.
Yeah,
Okay. All right, great. Thank you very much.
you're welcome.